Hello friends, today's topic of this lecture is inheritance. As we all know, reusability is an important feature of object-oriented programming. It is always better to create something from the existing one rather than starting from the scratch or creating from the scratch. So, C++ supports inheritance by the way that we can create new classes using the properties of existing one. The existing class is known as superclass or base class, and the new class is referred to as the subclass or derived class. Main advantages of inheritance are it takes less time to create code using inheritance because we are using the existing classes, so we don't have to add all the features in a fresh way. Second is code is small because some features are in base class, so we don't have to write that features again. For example, one more thing, derived class inherits some or all of the features of base class. It depends upon our coding. We are inheriting all the features of base class or we are inheriting some features of base class. For example, in this figure, there is a base class having features A, B and C, and a class is derived from this base class inheriting two features, feature A and B from the base class, and this class is defining some features of itself, that is feature D of derived class. Depending upon the number of base classes from which we are inheriting a class, or depending upon the number of subclasses which have been derived from a base class, there are different types of inheritance, or we can say there are different forms of inheritance. We will see them one by one. First is single inheritance. Single inheritance means there is a subclass which is derived from only one base class. That is, there is a base class and only one class is derived from that base class. For example, a child is inheriting the properties of its parent, his or her parents. So, a class parent is there and a derived class or a subclass child is there. So, child class is inheriting properties of parent class. Second type is multiple inheritance. Multiple inheritance is something in which a class is derived from two or more than two base classes. For example, the final marks of a student depends upon the sessional test score of that student, attendance in the class, university exam score, performance in the class, or some extracurricular activities. So, we have different base classes and final marks is the derived class. Or you can say a child or a human being inherits properties of his parent. Mother, father both. So we have two classes, base class 1, parent 1, base class 2, parent 2, and the child is inheriting the properties of both the classes. Next is multi-level inheritance. In multi-level inheritance, a subclass is derived from another derived class. For example, your father is inheriting the property of his father and you are inheriting the properties of your father. So, the base class is there and intermediate base class is inheriting the properties of base class, and then the derived class is inheriting the properties of intermediate base class. So, the derived class indirectly inheriting the properties of base class. Next is hierarchical inheritance, where a number of subclasses are derived from a base class. For example, we have a base class student, a student of any type. Either it's a student of arts, it's a student of science, it's a student of commerce, it's a student of engineering, all students having some common features. For example, his or her roll number, his or her enrollment number, his or her college name or university name. So all common features can be placed in base class, that is student, and all other features which are unique to a particular student or a class of students can be kept in derived classes. So all the derived classes inherit the common features of base class and having some features of their own. Next is hybrid inheritance. Hybrid inheritance is a combination of two or more than two types of inheritance. For example, in this diagram, parent class is inheriting features of grandparent class. It is an example of single inheritance. Next, child 1 and child 2, two derived classes, are inheriting the properties of parent class, which is an example of hierarchical inheritance. So in the same code or same diagram, we are using single inheritance and hierarchical inheritance. So it's an example of hybrid inheritance. Now, derived class. How a derived class will be specified in relation to the base class? General form is we use the keyword class, which is written here in bold case, then derived class name, then visibility mode, then base class name. In this way, the derived class will inherit some of the features of base class. Visibility mode here specifies how the features of the base class are visible to the derived class members. Along with this, we can also define some of the features of derived class in the body of that class. For example, we have shown here members of derived class. Visibility mode can be private, protected, and public. Depending upon the visibility mode, the members of the base class will appear in the derived class. Visibility mode is optional. By default, it's private. For example, we have a base class parent and we are deriving a class child from the parent class in public mode. So we have written class child public parent. Access control. A derived class can access all the known private members of its base class. That means private members of base class can't be inherited. So, base class members that shouldn't be accessible to the member functions of the derived classes should be declared private in the base class. Different access types or different visibility modes are summarized here. If here on the left hand side it's shown base class visibility, that means a member is private, protected, or public in base class. Now, if a derived class, when we deriving the subclass from the base class, then visibility mode may be public, private, or protected. If visibility mode is public, then private members not inherited, protected members of base class remain protected in derived class, public member of base class remains public in derived class. Next, if visibility mode is private, then again private members will not be inherited, but both protected and public members become private in the derived class. Next and last is protected mode. If visibility mode is protected, then again private members will not be inherited, but the public and protected, both type of members of base class will become protected in derived class. It's all for this lecture. Next lecture, we will discuss all these types of inheritance using code. Thank you.